And hello to all of you who are joining us from Edmonton and beyond. We are 2 minutes to our live broadcast that is taking place on Facebook, on YouTube, on DRIFCan's YouTube. I want to give you a couple of minutes to settle in, perhaps get yourself a drink, relax, gather the family around for what is going to be a very powerful and informative hour on diabetes research, groundbreaking, world-renowned research that is taking place in Edmonton, and reasons why we all need to get on board and support that research because it is changing lives, and Dr. James Shapiro is closing in on a cure. It's very exciting. So I will give you a couple of minutes. I don't want to start the broadcast before the time begins. So consider this your 1 minute warning. 1 minute warning before we begin. So settle in with your family and get ready for a rich conversation. And Kathleen Gibson, hello to you, wherever you are joining us from. You asked, will this be available to view later as well? Yes, it will be, Kathleen. It will live on DRIFCan's website. That is DRIFCan.com, DRIFTCAN.com. So you can find it there. You can also find it on my Facebook site as well, which is Carrie Dahl. And Janice Carissa says, hello, looking forward to it. Hello to you, Janice, and thank you so much for joining us for this evening. If you're just settling in, I'm seeing lots of numbers growing. Please don't hesitate to introduce yourself. Go to the top of the broadcast and give StreamYard permission to use your name for this broadcast so that James and I can interact with you and use your name and use your questions as they come in. We want this to be interactive and beneficial to all of you who are joining us this evening. We've got about 30 seconds to go before we begin. Hello, Rhiannon. And she says, hello, Carrie. Happy to join in the conversation and learn. It's going to be a powerful one, Rhiannon. Thank you so much. Nidheesh, thank you so much. Yes, joined here, looking forward. You work with Dr. Shapiro. It is wonderful to have you with us. Mona Lisa, looking forward to it. She says, very blessed to be a patient of the Edmonton Protocol. That's wonderful, Mona. Congratulations. Yes, you must be thrilled to be in such capable hands. Sandhya, hello, looking forward to this. Welcome to you. Thank you for joining in our conversation. Weigh in. This is a conversation, an opportunity to learn, and I understand that we have people from around the world that are going to be joining us this evening. Lots from the United States as well that support Dr. Shapiro's research. So we're looking forward to having you weigh in with your voices tonight. I look at the clock, and I want to stick to time. This is going to be a power hour of information. And so on that note, at 6:30, I say, ladies and gentlemen, researchers and scientists, patients, families, and friends joining us from around the globe. Hello and welcome to an evening with world-renowned diabetes researcher, Dr. James Shapiro, in support of the Diabetes Research Institute Foundation of Canada, more commonly known as DRIFCan. My name is Carrie Dahl. I was a longtime television news anchor turned public speaking coach and podcast host. I am honored to serve as your MC for tonight's virtual event. We appreciate the time all of you are taking out of your lives to spend with us tonight and to learn more about Dr. Shapiro's work and help us raise important funds for his research to accelerate a cure for diabetes. We want this event to be informative and interactive, so please, we encourage you all to join in on the conversation. I just see Milton from Montreal joining us, saying hello. Welcome to you, Milton. Welcome to Natalie from Poland. That's wonderful to have you with us. Welcome to Jody LG. Hello to Georgia, mother and sister to type 1 diabetics. So excited to learn more. I'm going to be bringing you all into the conversation. Hello, Rob Otway. Looking forward to tonight's conversation. Rob, of course, is a board member. Sarah says, hello, thank you for this. We are looking forward to this, as am I. That is the kind of conversation I want to see happening. And I know Dr. Shapiro welcomes your questions as well. So The format for this broadcast over the next 60 minutes is going to go something like this. I'm going to begin by giving you some background about DRIFCan. Then I will do an extensive interview with Dr. James Shapiro, where we will be welcoming your questions. Matt Mandruziak, chair of DRIFCan board and dad to daughter Ella, who is also a type 1 diabetic, will be joining us a little later in the broadcast to talk about the future goals for the organization and explain how the funds that are raised tonight will have a huge impact on Dr. Shapiro's research. From there, we will wrap up the evening at 7:30 sharp. We have Atkins saying hello from Airdrie, Alberta. Prusik, looking forward to learning more. Antoinette, my 8-year-old granddaughter was diagnosed with type 1 diabetes this summer. Paul M. Paul, 4-time transplant recipient, and my wife, Joanne. Jag is also pleased to be here. Thank you all so much for introducing yourself, for weighing in on this conversation. We welcome all of your comments and your feedback tonight. So with that, we begin with a little more information about DRIFCan. Now, the mission of the Diabetes Research Institute Foundation Canada is to accelerate the cure for diabetes by directly funding Dr. James Shapiro and his team at the University of Alberta. DRIFCan is a grassroots foundation, and 90% of the funds go to the research. They only have one employee who works from home and a volunteer board of 14 people, along with many other volunteers. They are small, but they are a mighty not-for-profit, and they were established to help fund the world-famous Edmonton Protocol, where islet cells are taken from a donated pancreas and transplanted into the liver of the recipient. And we, of course, will talk much more about that Edmonton Protocol shortly. Dr. Shapiro and his team also did the first ever human stem cell transplant trial. The goal now is to move from using donated stem cells and begin using a person's own stem cells so that anti-rejection medication does not have to be taken. We're going to dig into all of that information further momentarily. There's a lot of information to cover tonight in this research. It's changing lives right around the globe, but funding is crucial to its success. And I want to take this opportunity to remind all of you who are watching tonight, wherever you may be, that tonight is an important fundraiser for DRIFCan. Further information can be found on their website, DRIFCan.com. That is spelled DRIFCAN.com. That is also the place where you can make a donation tonight in Canadian or American dollars. And Matt will be speaking much more about that a little later in our broadcast. So now, without further ado, it is my pleasure to introduce our guest tonight, Dr. James Shapiro. James Shapiro was born in Leeds, England, son of a family doctor. He studied medicine in Newcastle and trained in surgery in Bristol. He developed a long-standing interest in islet transplantation as a medical student. He has been on the faculty of the University of Alberta since 1998, where he now holds the Canada Research Chair in Transplantation Surgery and Regenerative Medicine. He directs the Living Donor Liver Transplant and the Islet Transplant programs here in Edmonton. He was the lead investigator on the famous Edmonton Protocol cell transplant treatment for diabetes. He is the Project 1 lead for the CNTRP, which is actively researching ex vivo organ transplant repair. In 2015, his team began first in human trials with embryonic stem cell derived insulin producing cells transplanted in an immunoisolation device. Friends, over the years, as a former television news anchor, I had the incredible opportunity to interview Dr. Shapiro many times about his numerous breakthroughs and his incredible work. I'm so honored and I'm so thrilled to have this opportunity once again tonight. Wherever you may be, please join me in welcoming the one and only Dr. James Shapiro. Hello, Dr. Shapiro. It's so nice to see you, and we're back together again.
Can't believe it. 20 years ago or something, and we were interviewing over the Edmonton Protocol. And You were filming in the back room by
You're
radiology.
right.
Yeah,
You're
amazing.
so that was some 20 years ago, wasn't it?
Yeah.
I have a Dr. Will Herga who says, I was being educated in U of A of dentistry and pharmacy building when Dr. Shapiro revealed Edmonton Protocol. Keep up the research drive. Isn't that lovely to get here? I'm going to put his comment on to get feedback like that people know you, remember your work, and are thrilled to be working in the same city as you.
Well, it's very touching, but I'd be the first to say, and I need to say it right up front, that although I'm sitting here tonight talking to you, there's a huge number of people behind me that are doing the real work. And Nadish, who's on there, he's working very hard in the lab. We'll talk about the stem cell work in a bit, but it's not just me. It's a phenomenal team of people that are all driven to get to the same end, which is a potential cure for diabetes.
Well, and I know you have a brilliant team working behind you that have so much respect for you, and people around the world that are following your work. Here is evidence of that. They say, good evening, Bob and Kathy Inglis from Portuguese Cove, Nova Scotia. So you know a lot of these people that are wondering. I got to put my glasses on so that I can make sure that I'm seeing all of these comments coming in tonight. Dr. Shapiro, I want you to take us back just briefly. I have to ask you this question. Where did your interest in diabetes research come from? Why this area of research?
I knew from a very young age that I wanted to be a surgeon. And people told me surgery was really competitive to get into. So when I went to medical school in Newcastle, I went to visit a surgeon because people had said, well, if you can do some research, you'll get ahead of the curve a bit and your CV will stand out a bit. So I went to see him, and he gave me 2 pages, the type sheets, and on that page, halfway down, was this islet cell transplant, and he had several projects with islet cell. I knew nothing about what an islet was. I certainly knew nothing about diabetes, but I was intrigued by it. And so I set to work with him. I spent a year working in the lab. John Farndon was his name, and I worked with a colleague of his, Tom Leonard, as well in Newcastle. And we spent the year transplanting cells in mice and rats, trying to cure diabetes, basically following the work that a scientist who discovered that islet cells could be transplanted. This was a pathologist by trade in St. Louis, Paul Lacey. And he was the very first person to show that you could cure diabetes in a mouse or a rat by transplanting these cells within the pancreas. So we were copying that work. And in fact, we were playing with the immune system to see if we could somehow freeze these cells and then thaw them out again and make them less sensitive to immune rejection. And that was sort of my first taste of it. I have to say, virtually every one of my experiments failed. I worked day and night. And John Farndon was a very tough taskmaster. He had me sleeping in the mouse house all night, measuring blood glucoses every hour on these poor mice and rats. And I was terrified to handle the mice and rats when I first started. Were you
really?
Oh yeah, I was terrified, scared of them. Pick them up, and one would slough its tail, another one would run around. I'd be terrified it's going to bite me. I had to. It was a long journey at the beginning, I have to say. And at the end of that year, I wrote this huge thesis. Most of it was all negative results. And I felt very cheated by research, but I'd worked very hard on it. And the opportunity much later for me came up to come to Canada, to Edmonton, to work with Norman Knieteman and train in liver transplant surgery. And I knew that he and his team and Ray Rajot and others had been involved with islet cell transplantation before. And this was such a rich environment to be able to carry on experimental work. So I was able to pick up the threads. And this time, most of my experiments worked, whereas previously I'd had my fingers burned. So that's the beginnings for me.
That is a great story. And I'm just so glad that you didn't give up at the beginning when the mice were getting the best of you at the beginning of your research. Because if we look at numbers, oh my goodness, when we talk about the number of people that are living and diagnosed with diabetes around the world, it's huge. It really is.
It's frightening. If you look there, as that clock ticks on, every 6 seconds somebody dies from diabetes or a complication from diabetes. And if you look at the cost there, it shows you on the screen $1.3 trillion US. So more Canadian. Every single year globally is spent in managing diabetes and its complications. It's a phenomenally expensive disease. In fact, it's the most expensive disease now by far, at least in the US, and it will be in Canada. And it's strangling our healthcare systems. We cannot survive long term. As you know, right now in the world, there's 400 million people with type 1 and type 2 diabetes and other forms of diabetes, and it's going to rise to around $600 million, 600 million people as this continues. And that $1.3 trillion is going to be completely unsustainable. That's why they call it the tsunami. And we have to find a permanent solution that's going to cure this disease, or our health care systems are just going to simply implode.
Well, we had a step in the right direction some 100 years ago with the development of insulin, but that was just the beginning.
Yeah, you know, that this picture is phenomenal. This is a picture of Frederick Banting, who was working with Best and MacLeod. So Frederick Banting was a medical student like I was when I first began, and he had this idea that he could tie off the pancreatic duct in dogs was where he did his first work. And this is the notebook of his, handwritten. It's almost 100 years ago to the day. So you can see there, you know, October the 30th, he was too tired to get the date right. He was also too tired. You can actually see his spelling of diabetes was wrong. He couldn't spell diabetes. But he worked out this was his big idea, that if he did this in dogs and tied off the pancreatic duct, he'd be able to extract more insulin. And that was the very beginning. So when he did that, the idea, for him too, the experiments didn't work the first time round. And they needed a biochemist who came from the University of Alberta here, James Bertram Collip. And he was an expert in all sorts of chemistry. And he figured out that if they added alcohol to extract the insulin, because he knew that the compounds in the pancreas might be soluble in alcohol, that was the key that sort of unlocked the success of insulin working in patients. And then, so 1922 is the first year that a patient was treated successfully, and insulin became more widespread and available, at least in Canada, and then subsequently across the globe. And it has of course saved countless lives, but it's still far from a perfect treatment.
It is. And so we take a massive leap forward, and along comes the Edmonton Protocol, and you went in a different direction. Tell us about how that Edmonton Protocol was created and the thinking back at that time.
Okay. So as I told you, I was training in transplant surgery. I was doing experiments in the lab in Edmonton in islet cell transplantation. And I went away to do a number of fellowships in Japan to learn living donor liver transplant, to Baltimore in Maryland to train in whole pancreas transplant surgery. And because of my background and all that, I was asked to run the islet cell transplant program. There had been a program here before. It was led by Garth Warnock and Ray Rajotte and Norman Kneteman and Eddie Ryan. And they had treated a handful of patients at that time, so a few of whom had been able to stop insulin for very short periods of time. But if you look at the worldwide experience with islet cell transplantation, when I took over, there were around 250 attempts at doing this transplant in patients, and fewer than 8% of patients were able to come off insulin and stay off for longer than a year. So I looked at all of that and saw that the anti-rejection drugs that were being used were not good for the islet cells to survive, and were also sort of antiquated and not very effective in stopping rejection. So the Edmonton Protocol was built around all the failures and all the sort of just really to give it one last kick at the can, if you like, to see if we could get it to work. So what I built into there was to remove the steroids, which were the mainstay treatment for preventing rejection, and exchange them for some very powerful anti-rejection drugs and antibodies. And then we also gave infusions of 2 or 3 fresh preparations of cells, which hadn't really been done routinely before in patients. And sure enough, one after the other, the first 7 patients, as you remember and interviewed me,
yes,
in this department here where the x-rays are up right now, the first 7 patients all were able to come off insulin and stay off insulin for up to a year when we wrote that paper up in the New England Journal of Medicine. And I have to say, we were not really prepared for that level of success. I was very junior in my career at university. I was fairly junior still as a researcher, but I was left for this orphan program that people thought was never going to succeed. And all of a sudden it became successful. And I presented at this international meeting, and it created quite an uproar. There was a standing ovation for me at the American Transplant Society meeting, and I'd never come across anything like this. And I'm normally a fairly private person. You might not think so when I join you for an evening like this, but I am. And I was pretty bowled over by all that. And I got back to my office in Edmonton a few days later after that meeting, and there were thousands upon thousands of letters from desperate patients like Bob, who wanted to come off insulin and have a chance at a different kind of treatment, a cell transplant based treatment that was an alternative to insulin that might perhaps be better.
I think everybody who saw that video of Bob Teskey, because we just saw him on the screen there, and I'll never forget that as a journalist, he threw his insulin away and all of our jaws dropped to the ground. It's like, what? You're diabetic? And that was the big news. And it was just so massive at that time that he no longer needed it. And that was the first patient March 11th, 1999. Do I have that date right?
Exactly right, yeah.
Okay, so Melanie Hubbard, this is a good, and she just jumped ahead to my next question. How many transplants have been done around the world, and how many sites are doing them?
So that's a great question, Melanie. Well, in Edmonton, we've done around 350 patients, but that's around 600 transplants because most patients need more than one infusion. Around the world, there's been around 2,000 islet cell transplants following our protocols, or in fact, improvements on the protocol since we first described it. And it continues to grow. But I would say that it's not grown perhaps as fast as it could have done. We've worked very hard with trials in the United States. We set up trials that there was about $100 million was set aside by the NIH to carry out multiple trials in the US, and we participated in that. But those trials went forward. The trials were successful, but they're still sort of battling with the Food and Drug Administration, the FDA in the States, to try and get approval and funding for that therapy. So there would be a lot more islet cell transplants done in the States if they had full approval. So there's around about 40 centers that have been practicing islet cell transplantation over the years, many of whom came to Edmonton to train with us. And it's been a real privilege to watch that journey and watch these trials grow over the course of time.
A few people saying, Kathleen Gibson says, it has been a life-changing treatment for sure. I have had 3 transplants. Prusik Innovation says, glad that you are here, Kathleen. My boy's friend says, Jody Elgie's mom had it done. I still remember when she got the call. We were at football practice. I think it was around 2002, perhaps. So obviously your work is impacting countless lives. But the islet cells from the cadavers were not the answer. Why?
Well, there you go. So the issue is that this was really to test if cell transplantation, replacement of cells inside the pancreas that make insulin, by putting new cells in there, could you effectively cure diabetes? Well, we showed yes, you could reverse diabetes, but we never saw islet cell transplantation as a real cure. The reason being that there are never enough organ donors to go around. We know that there's 400 million people in the world with all forms of diabetes today, and we know there's only a handful of organ donors. We'd like more organ donors, but we know that organ donors are never going to cure. So that's why we need something better. And the other big driver for us was the anti-rejection drugs. They have side effects. They can slightly increase the risk of cancers, certain cancers. They can increase the risk of certain life-threatening infections. So for somebody that's doing well with diabetes and has good control with insulin or an insulin pump and is managing fine, we wouldn't recommend an islet cell transplant today. But if we could carry out a cell transplant from a limitless source of cells, such as a stem cell like you see on the screen, and then carry out the transplant without the need for any anti-rejection drugs, well, all of a sudden that breaks the sound barrier. That really would be a cure for diabetes if we could get it to work.
I love the way that you put that. That does break the sound barrier if you could get that to work. So there is a big if with that. Tell us what it is. Okay,
so we've been working with these stem cells for a while now. I've had a collaboration with the lab and with a company called ViaCyte in San Diego for almost 20 years, since the Edmonton Protocol was first announced. I discovered there was a company that had access to an embryonic stem cell that could turn into basically make islets, a limitless source of islets. Now, with that, it's still a what they call an allogeneic product, which means it can be rejected. So you do either have to take anti-rejection drugs, or you can try to put the cells inside a device that will protect them from the immune system. But that's a little bit challenging in itself. So we carried out transplant trials with this in 2014, 2015, and we're continuing those trials now with ViaCyte. We're beginning to see some very positive signal in a proportion of those patients who are beginning to make insulin that's detectable in the bloodstream, have cells as we take them out and take biopsies of those cells and sample them over time. We can see them turning into human islets. And it's the beginning of a success, but it's that has still got a long way to go before it's anything like the equivalent to the Edmonton Protocol. So these are the embryonic stem cells. But how could we carry out a transplant ultimately and need no anti-rejection drugs? Well, that would mean having your own cells and also doing something to the immune system to make sure that if you have type 1 diabetes, which is this autoimmune diabetes, because the immune system in type 1 diabetes attacks the cells inside the pancreas, inside the islet, the beta cells that make insulin, and it can happen again in a transplant. So we need something to stop that process as well. So that's why there are some challenges, but we're very optimistic that these can be overcome. So,
Dr. Shapiro, I want to stop you there, and I want you to talk about why stem cells. Why are they proving to be the answer? If you can explain it to us.
Right. So we're all made of stem cells. You began like I did as a tiny blastocyst, a 5-day-old ball of cells. You know, we're all gone different journeys in life, but that's how we began. And inside that little ball of cells, by day 27, the pancreas is formed, and these islets are now detectable inside a human embryo. 27 days. So there you go. It takes 27 days inside an embryo to make these islet cells that make insulin. And then they take a long period of time to mature after that, but that's the beginning. And so we've been trying to follow that journey again in the lab, not necessarily our own protocols, but Nadish is on there, and he's done all the hard work in the lab, adding all the growth factors, changing the media with the help of Rena, our technician, and a number of other brilliant students that I've had the fortune to work with. And there we are, we're basically culturing these cells that are taken from human blood. So first, I told you about the embryonic stem cells, and now I know this is confusing because there's a lot of information. I'll try and simplify it for you. What we can do now is take a blood sample from a patient from a vein in the arm, and we can take a certain number of cells from that, and then we can turn those cells into these what are called iPS cells, or inducible pluripotential stem cells. And what these cells have is the capacity to change and wind back in time to become just like those cells inside the embryo. And there was a brilliant scientist who got the Nobel Prize for that work, Shinya Yamanaka, in Kyoto in Japan. And what he discovered is that he could take these cells from the skin when he began that work in 2007, and he could wind them back and then turn them into heart cells. And since then, and also with the team at ViaCyte, you can see the picture here with us carrying out the first transplant with ViaCyte. The scientists at ViaCyte, Kevin Damore and colleagues, were able to develop these protocols that would allow the iPS cells, these same cells from the blood, to be developed in that 27-day protocol to turn them into insulin-producing human insulin-producing cells. And the beauty here is if we could make patients' own cells, then it's a cell that could last the patient's lifetime, and it could work not only just in type 1 diabetes, but in type 2 diabetes, which of course is 10 times more common than type 1.
This is so huge. There's so many questions coming in, and I want to acknowledge a few of them here. First of all, I wanted to draw attention to a question from Clarence, and he said, some people listening have an interest in protokinetics as it pertains to the trials. Can you talk a little bit about that, Dr. Shapiro?
Yeah, so Protokinetics is an interesting company that approached me some years ago, and I had a really great graduate student in the lab at that time, Boris Gala Lopez, and the Protokinetics team came to us and they said they've got this molecule. It's got a very cool name. It's called anti-aging glycopeptide, AAGP. In fact, we should probably all be taking it. So AAGP, and it sounded far more miraculous than it could possibly be. But I said, well, why don't you send me some, and we'll test it out in the lab and see what we can do with it. So we took some human islets, and we treated it with this anti-aging compound, AAGP, and we found that it really protected the islets when we cultured them. And when we transplanted them and added the compound, the anti-rejection drugs that we use today for the islet cell transplant, particularly the drug tacrolimus, which is normally quite harmful to islets, we found that it protected the islets from damage and attack and allowed those cells to engraft and function much better than they did before. So that led very rapidly. And here's an example of how wonderful it is to work and special it is to work in Edmonton. So that work happened, and within a year of testing that and publishing it in mice, we started the very first trial in patients with that same compound. And we're in the midst of that trial now, and we've got ongoing data. It looks promising, but we don't have all the answers yet with it. But AAGP, I think, has a lot of potential.
Okay, I want to make sure that everybody is following this, because Dr. Shapiro, with all due respect, your mind is just in the way that you talk. There's a lot going on here.
Yeah,
so I'm going to see if I can summarize this. So we started way back in, what was it, in 1999 with our first ever islet cell transplant, where you would isolate and take the islet cells from the pancreas of a cadaver. You moved into embryonic stem cells, that you started using those, but those weren't the answer now you're finding that if you could just grow a person's own stem cells, that would be the answer. Have I followed this correctly?
That's the ultimate dream. Now there's a lot of challenges between where we are now and where we want to be. Some of it is why we're here tonight. We need some funding. We need around $24 million to drive that research, to pay for the reagents, to pay for the equipment and the scientists to take it from where it is today to a real cure tomorrow. And right now with Nadish there, so we've been able to cure diabetes in mice with human cells taken from the blood. So that is like
huge.
That's like alchemy. I think of it as alchemy. Turning mud into gold. And that's basically what Nadish and the team have been able to do. Basically take blood, wind it back in time, wind it forward, make them into the islet cells that make insulin, transplant those into mice, show that they make human insulin. And that's a great start. It's really exciting, really promising. Here you go. This is what we've been doing, personalized medicine. But now, how do we take that to treat 400 million people with diabetes? That is a huge challenge. And so I know we can probably treat the first handful of patients, 10 or 12 patients in Edmonton, with a lot of technicians and a lot of reagents and a lot of funding. But how do we take that, when it's successful, and it will be, how do we take that to a robust cure for everybody in the world? And here's a long list of a shopping list. It's too small to read, but you can see there's about $6 million of equipment alone that's needed on that list that we need right now in the next year or two to drive that work forward. But we're also working with some other brilliant scientists across the world. Tim Kiefer in Vancouver, who's done a huge amount of work in developing these stem cells. Christina Nostro in Vancouver, who's also a brilliant stem cell scientist. But also a number of scientists that are expert in areas that we know nothing about, such as machine learning, artificial intelligence, robotic engineering. And we've got a liaison now with a company called Lonza that has a room, they call it the Orchard, where you can basically grow cells automatically, all robotically. We may have a picture of that coming up later on.
I know that I want to bring this picture up right now, and it looks like it reminded me of something that I saw in the movie Avatar. That was my first, for anyone who's seen the movie Avatar, take a look at this. Now, it's not big enough to hold humans like the movie does, but Dr. Shapiro, speak to this is your ultimate dream of what you want to do with the funding. So talk a bit more about that.
Yes, so this is real right now. So these pods exist. Lonza has them. They call it the Cocoon Project. And this orchard where they grow the cells, they very generously are going to provide some of this equipment to us and help us develop it to automate the process so that we can go from, mice to patients to a cure for everybody over the course of time. And this is what it's going to take. And I think at the end of the day, it does look like Avatar or something like a space station. But I think at the end of the day, we're going to end up with several manufacturing facilities that look like this one. And we'll be able to make cells that are your own cells, that are compatible with your body. We may have to engineer those cells a little bit to prevent diabetes from coming back in those patients, like many of the ones on that are on tonight that have type 1 diabetes, to prevent autoimmunity from coming back. Or there are some other processes that we can use to switch off autoimmunity. But I really believe that this has the potential to be a robust cure for the future of diabetes.
And it takes the funding, because the list is long for equipment and the labs are complicated, and you're relying on artificial intelligence, are you not?
Artificial intelligence and mass manufacture machines. So this machine that you can see in front of you right now, this 250 high throughput perfusion system, is a robotic controlled system that costs this on its own costs $1 million. Well, we don't have access to that right now. We've got a beautiful facility that Greg Corbett has in the Alberta Diabetes Institute in Edmonton. Here you go. This is Greg, a picture of Greg in the Alberta Cell Therapy Manufacturing Facility. And this facility right now is being used to generate some immune cells for some trials in patients, but is really set up long term to allow us to move upstairs here and start generating the cells that we need to cure diabetes with these stem cell types of approaches. And so, I've been talking to Greg. We work very closely together. We're looking forward to being able to take this forward in Edmonton to treat the first handful of patients and then work out the journey from there to make it a cure for everybody.
So how close are you right now? You said essentially in mice, you were able to cure diabetes by using their own stem cells. Is that correct?
So we can put human cells into special kinds of mice that don't have an immune system. We can make those mice diabetic before we put the cells in. And the human cells taken from the bloodstream from patients with type 1 diabetes and other forms of diabetes can reverse diabetes very effectively in those models. So that tells me, that if we can scale that up, for sure it'll work in a patient. The Islet cell Edmonton Protocol works reliably in patients, but it doesn't work necessarily long term for everybody, although there are a few patients that are 20 years out now from the transplant and still insulin free, but not the same for everybody. So how do we make these cells better? How do we make them more robust? And this is the journey that I really believe is going to get us there. But there's a huge amount of work ahead of us.
Dr. Shapiro, great question from David Dowling. Is it a cure for type 1 or type 2 or both? Well,
both. And in fact, it might work better in type 2 to start with than in type 1, because we wouldn't have to contend with the autoimmunity pathways in type 2 diabetes. We do have a trial that we're moving forward with, which is now including children and adults, which resets the immune system in somebody just diagnosed with diabetes type 1. And the idea there is we switch off autoimmunity and induce repair inside the pancreas. That doesn't involve cell transplants, but we might be able to use a concept like that and combine it with the stem cell therapy to allow these cells to survive in type 1 as well as type 2. So there's lots of strategies we're working on and will further develop over the course of time, collaboratively with all these brilliant international scientists that we've got the opportunity to work with to take it to the next stage.
How important are the funds that are raised tonight and beyond? Like, essentially, they enable your research. Is that the bottom line?
Well, the funding is the key to everything. Without funding, we can't do the work. We can come up with great ideas and be enthusiastic about them, but we can't really test them robustly and make sure they're safe and make sure we can deliver on our promise without the funding. And I've been incredibly grateful to DRIFCan over the years. Melanie Hibbard, Matt Mandruziak, the big team of people that sits on the DRIFCan board and have worked tirelessly to try and help us raise those funds. We've been so incredibly grateful to them. But the funding is absolutely the key. No funding, no delivery.
A great question here from Milton. He says, for parents with diabetic kids, any hope using their baby teeth for the stem cells, or is it worth banking them for the future?
Well, that's a very unusual question. I've heard lots of questions over the years. I've never had one about baby teeth. But, well, the baby teeth are not really supposed to be kept. The tooth fairy takes them. But in all seriousness, there's lots of questions people ask about, not necessarily about baby teeth, but about cord stem cells. Could you use cord stem cells? Should we freeze those? And there's lots of people now that have frozen cord blood, and they ask me frequently, could we thaw this out and use that? Well, probably the cord blood would work as well as the blood samples that we take, but it's obviously if it works from just a blood sample, that's by far going to be the easiest tissue to use.
And as you talk about that, here's the
There we go.
question from Victoria. Is there anything that can be done for children with type 1 that had their cord blood? So there you go, Victoria.
Good question, Victoria.
Yes.
Keep the blood banked, the cord blood bank for now, I think, because as these protocols mature, I think there will be an opportunity in the near future to start testing that. But I would save it now. That's precious.
Great question, Victoria. Thank you. I want to take this moment and remind everyone to like this broadcast on Facebook and on YouTube so that more people can have access to it and can watch it. Let's bring the viewers in. Let's spread the word about DRIFCan and the amazing work that Dr. Shapiro is doing. Another great question from David here. He says, Dr. Shapiro, this approach, does it have the potential to go beyond diabetes to other diseases?
Well, that's a great question, and absolutely, David, it does. So, stem cell therapies are being used in multiple different approaches in a large number of countries, in fact, right now. So, for example, with heart disease, we can potentially make iPS-derived cells that are basically heart cells, and you could inject those cells into, say, somebody that's just had a heart attack and has lost the function and the ability for that heart to contract. And so you could put new patients' own stem cells there and allow them to regenerate and repair. Same thing with the liver, with the surgeries that we do. Perhaps many of the complex surgeries we do today won't be needed in the future because we could perhaps fill the liver with stem cells and repair it instead of having to do a transplant. So there's lots of different opportunities. In eye disease, in blindness, stem cells, there are stem cell trials moving forward right now to treat certain forms of blindness, and they're proving to be quite effective.
Wow, that is so much promise in that regard and opens up a whole new world to you as well as you take step forward. I have some great questions coming. Here's one from Cheryl. She says, are previously transplanted patients able to access stem cell therapy as well?
Hey, Cheryl. Hi, how are you? So absolutely. So I look upon you and many people that are on this chat tonight that have had islet cell transplants. You were the brave individuals that came forward initially when I looked you in the eye and said, I don't know how this therapy is going to work. I can tell you there are potential risks with it, but I can't promise how well it's going to work short and long term. And you were brave enough to come forward and be volunteer for the early trials. And thank you, all of you, collectively for that, because we wouldn't be here today doing what we're doing and able to advance things for tomorrow without the contributions that you've made, brave contributions that you've made in taking things forward. But absolutely, there's no reason whatsoever that a stem cell therapy could not work in a patient that's had a previous islet cell transplant, for sure.
Wonderful. Great promise for you, Cheryl, and so many other patients. I want to talk about this question from Jag. It's more scientific. You must be a researcher or beyond. Would you expect the iPS-derived stem cells to have foreign body response or immune system response, Dr. Shapiro?
Wow, Jag, you asked. Jag's a very smart guy.
Clearly.
He works for Oracle. But don't let it fool you. You think that he just be a computer geek, so he'll only know about computers, but he knows absolutely about everything. So I need to see that question up again. Is it possible to see it?
Yes. I'll bring it back up.
No, sorry.
Here you come, Jag. Okay.
Yeah.
Would you expect? Yes.
Yeah. So okay. So I think it depends on where you put those cells. So this foreign, we can talk about the foreign body response, and I don't want to make this too scientific or complicated for everybody, but let me put it very simply. If you get a sliver or a splinter in your finger, your body tries to reject and push that splinter out, and it's called the foreign body response. So when you put foreign tissue in, it can be rejected that way and destroyed, but that's usually in the skin. And some of the stem cell trials are where we've been first in human trials where we've had to test things in the skin first. We've seen those kind of responses. Not necessarily, though. So I think as we prepare and develop mature islet cells from these products and put them into the liver or another ideal site, such as the liver in the future, then I think we will be able to overcome these kind of challenges. And the beauty here is we can make as many cells as we need to overcome and provide the normal reserve that a healthy, normal human being would have who doesn't have diabetes. So the islet cell transplants today, when we carry out a transplant, we only put a fraction in of the cells that a patient really needs to be completely cured. If we had a limitless source of cells, we put many, many more in, and we have the ability to do that with these stem cells in the future. So I'm not too worried about these foreign body responses, and I think they'll be completely controllable as we move forward.
Great question, Jag. Thank you so much. I love this question from Rob Otway. He says, so as this research is so promising, why aren't large charities or governments not stepping up to fund it? Surely it results in lower healthcare costs overall. Go ahead, Dr. Shapiro.
Well, there you go. So $1.3 trillion is a big expense for every government across the world to pay every single year. So if you put a fraction of that cost into finding a cure for diabetes, like we're putting right now, massive amounts of money into COVID research, as we should. How do we unlock the future? We do it by investing in research. So I can't tell governments what to do, but for sure, when there's something as promising as this, it needs to be we need to invest in it, test it to its limits, and make sure it's safe and that it delivers on its promise.
I mean, it is a lot of money, but we have to take those steps in the right directions. Dr. Shapiro, I want you to dream the dream, because there is a wonderful, it's a cartoon, it's a drawing that I want you to speak to tonight. And I saw this and I absolutely loved it. So talk more about this and what it means to you.
So this is the picture that Coldrell drew when he was 12 years old. He has type 1 diabetes, and he drew a picture of me in my office the day that diabetes was cured. And he's got a picture of me with nothing to do, staring out of the window. And on the upside down there, you can see Dr. Shapiro cures T1D, type 1 diabetes, in Time magazine, and all the insulin injections are in the garbage there. I do have some rather large feet there. That's interesting. I've not noticed that before. But anyway, again, as I said at the beginning, it's not just me. There's a huge number of people involved in this journey, and we're all excited together to get to a point where we really have a cure for this disease.
Great question from Cheryl Howell. She says, how do we turn awareness into investment? Age-old question.
Well, I will say that the DRIFCan's trying very hard. There's a subgroup in DRIFCan called Heading to 2022 that's trying to get 22 million Canadians to give $1 each to help with this research. If that happened, it would be amazing, and I believe it will. People are working very hard. So, yeah, we do need to transform this concept and dream into reality, and it's going to take a huge amount of commitment and drive. And I can't do that alone. I need all of your help.
You need help, like from Cole Byers.
There you go.
DRIFCan says there's a fun fact for all of you. Cole Byers has raised over $300,000 for Dr. Shapiro and his team. Tell me more.
Yeah, so I told you he's a 12, 13-year-old boy, and he lives in a small community, and he's gone around shaking the tin, telling people about the research, and he is so committed to helping us, and he's done that. That's so powerful, isn't it?
It really, really is. That speaks to the need out there as well. And Rob weighed in again with this comment saying, seems to me we should be thinking of this as an investment, not a cost. Really a no-brainer IMO. I like that.
Absolutely.
Closing thoughts tonight, Dr. Shapiro, before we move on. I mean, I want patients to understand a few things. Are you still doing the islet cell transplants from cadavers, isolating those islet cells?
Absolutely. We have a number of really exciting clinical trials ongoing in that area. We haven't given up on that at all. That is one area right now we're working on is a trial, first in human trial, with special kind of immune cells that avoid the need for anti-rejection drugs. So these are called Tregs, or regulatory T cells. We all have them inside our bodies, but we can expand those cells and outside the body and then put them back in. And we've got a clinical trial that we've treated a few patients with right now. We take the cells, a blood sample, we send it off by FedEx to San Francisco to a lab there at UCSF, where scientists Chrissy Tang and Jeff Bluestone and their team can expand these cells, these regulatory T cells, and then they ship them back to us. It takes them 2 weeks to make those cells. They send them back to us, and then we infuse those back into the patients, and we can give a quarter of the anti-rejection drugs and have the transplant still working with those. So we're in the midst of that trial. We're testing out its safety. We're testing out its efficacy. But there's an example, one of many examples of the clinical trials we're running right now. So we are still very much actively looking for patients for the islet cell transplant as we prepare for the future for these stem cell therapies.
Right. And are embryonic stem cell transplant a thing of the past now that you've moved into?
No.
You're still working with those?
No, that they are definitely not a thing of the past. These are moving fast and in parallel. So, for example, the company Viasite that I mentioned to you before has been working with another company now called CRISPR Therapeutics to edit their cells, the cells that they've been transplanting in our patients so far. And these CRISPR gene-edited cells are altered in a way that makes them completely silent to the immune system. So there's another example of a stem cell product that may have the capacity to be transplanted freely in patients with no possibility of rejection because the rejection pathways have been removed by this editing process. And we're very excited about that too.
That opens the door to this question, Dr. Shapiro, from Paige. She says, for individuals with multiple healthcare issues, will a transplant ever be possible, as taking immune suppressant drugs may affect the healing process of other health issues?
Yeah, so thank you, Paige, for that question. So I absolutely believe that we'll be able to make these cells work. And when we do, ultimately we'll be able to carry out the transplants with much less and hopefully with no anti-rejection drugs. If we do that, all of a sudden we bring a huge amount of benefit into the equation and remove all the risk. And that's where we're going.
I want to acknowledge the fact that as we are talking throughout the last 40 minutes, Dr. Shapiro, donations are already coming in on the website, which is so exciting. I want to acknowledge all the people who have already given and made donations to your work. We appreciate you. And I mean, the work you are doing is so important in this journey. And I just, Dr. Shapiro, I've always said this to you, and we've joked about this. I have no idea how you even sleep at night with everything that you have going on in your brain, and, you know, the progress, the incredible progress that you are making in your research. At what point, and I've asked you this question before, I'm going to ask you again, at what point will you consider it a cure for diabetes?
This will be a cure when we have a cell-based treatment that we put into a patient. It's either a one-off treatment or maybe it needs to be topped up over time, but that's it, done and dusted. You don't need to take anti-rejection drugs. The cells continue to work. You don't need any insulin. You don't have to monitor yourself. You don't need regular blood checks. You know, you're basically like back to normal. And that's where we want to be. We want to turn diabetes into a disease that was just like a common cold. It came and it went. That's the way it will be.
And how close? In your mind, how close?
Well, that's the biggest, dangerous, and maybe the most threatening question, because I told you there's a lot of ifs, ands, and buts. I can tell you where we are. It's hard to know what challenges we're going to face as we move up this journey. All I can say is we're very, very determined to get there, and the faster we move, the faster we will get there, and the faster we'll learn and iterate and learn and continue to improve. So, people with diabetes have this condition for a lifetime, unfortunately, and they don't want to hear another promise that's going to be done and dusted in 5 years. So you won't get 5 years out of me. You won't get me to say 5 or 10 or 15 years. I just don't know. All I know is we are determined. We're not going to give up. We're going to leave no stone unturned until we get there, and it'll take as long as it takes, but we will do our job and try and speed that process up. But we need your help.
Unquestionable when it comes to you, because like I said, I've known you for 25 plus years, and you have put your heart and soul into this research. And I know there's going to be a day when we will celebrate you, just like that little patient Drew, where you're going to be on the cover of Time magazine, and we are going to have a cure. And it's not just me. I want to acknowledge a few things. Jag saying thank you, Dr. Shapiro and his entire team, Carrie and Melanie included, and Dawson says, what an amazing dream and vision, Dr. Shapiro. David Hamill says, and it can and will be done. Bob Inglis says, agree, Jag, amazing team. Thanks, Melanie and Carrie. Dr. Shapiro, on behalf of DRIFCan and everybody who is watching around the globe tonight across Canada, I want to express our extreme gratitude to you and your team and the countless hours that you've poured into your research and that unrelenting vision that a cure is within your reach. As someone just says, as David Hamill says, it can and it will be done. And I know that you will get there. We have every confidence and we're here to support you tonight. So on behalf of everyone watching tonight, thank you so, so much for your time, for your vision, and for your expertise. And as many people are saying, Joan Husband says, thank you, Dr. Shapiro. I was one of the pioneers.
You were, Joan. Absolutely. Thank you.
And so many, like I could just keep going on and on and on. Thank you, forever grateful. And it goes on. So on behalf of all of the thank yous that are pouring in, I thank you as well for your time and for joining us tonight. I've enjoyed this. I've missed this.
Me too, Carrie. Thank you so much. Good to get together.
Looking forward to the next time when we do this, okay?
Absolutely.
All right, Dr. Shapiro, thank you so very much. So we're going to say goodbye to you just for now and move on with the remainder of our program tonight. And friends, it is now my pleasure to welcome Matt Mandruziak. He is the chair of the DRIFCan board, who also has a personal connection to the why behind this work. And Matt is going to join me and give some perspective on DRIFCan and the importance of raising funds. Hello, Matt.
Hi, Carrie. Thanks for having me.
It's so nice to see you.
I'm trying to make sure that I'm in frame here. So yeah.
You're in frame? Was that not a rich discussion? I mean, nobody can. Nobody can. We just wrap our arms around that guy and support him in any and every way that we can. And here sums it up. Dr. Will says, Dr. Shapiro and his team are the superheroes of diabetes research. And Grant Smythe said, I missed that one. You are the best, Dr. Shapiro. And Matt, I know you must feel the same.
Absolutely. Yeah. I've been involved in DRIFCan now for several years, but really never heard about Dr. Shapiro until I started to learn about the organization. And as soon as I heard him speak for the first time, as a father with a type 1 diabetic daughter, there was no way I couldn't get involved in something like this. Certainly what he was saying went over my head. I'm a simpleton when it comes to what he's talking about.
I think it went over most of our heads, but we got the understanding of just how important the strides are and what he's doing. So
100%.
So tonight you want to give some perspective on DRIFCan about why it's so important to donate to this and to support his work.
Yeah, absolutely. And just before I get going, I did notice a comment, I think, from Trent in the chat about heading to 2022, which was mentioned by Dr. Shapiro at some point. So just to clarify on that, and I've noticed David Hamill commenting a number of times. He's one of our key contributors to that volunteer group that's put together this great initiative heading to 2022 that was announced earlier this year as a 2-year fundraising campaign for DRIFCan, for the work that Dr. Shapiro is doing and his team, of course. Basically, it's a grassroots, mostly online opportunity for people to contribute. We're asking for $22 through that campaign, hoping to hit 1 million people. That will raise us $22 million over the next couple of years and provide Dr. Shapiro with a lot of the funding that he needs. So I hope that gives a little bit of clarification as to what that discussion was about. That is linked to our website as well. You can visit headingto2022.com for more information about that. It's just one of the multiple ways that people can contribute to the work that James and his team are doing.
Talk a bit, Matt, just about your perspective from a dad. I mean, you're board chair, you understand this, but your dad, and that hits very close to home.
It definitely did, and I know I'm not alone, and certainly my wife and I are not alone, but our daughter was diagnosed in 2012. She was 2 years old, came completely out of the blue, no lead up, didn't get sick, didn't get ill like a lot of patients do. Just we caught it at the right time. but it turned our lives upside down. It made everything that me and my wife and our family did. We had to rethink everything. It put us in panic mode. But the one thing that was constant from the beginning, even at 2.5, our daughter Ella, it was like nothing. It was like water off a duck's back. She handled everything amazingly, still does. She turns 10 on Saturday. Wow. Actually, she's got an insulin pump. She's got constant glucose monitor, all that stuff. Has to make sure she's counting carbs at school now that she's back, all those things. And it's second nature to her right now. And so to see James and the work that DRIFCan is trying to do, and the hope that he provides and his team provides to someone like me, to my daughter, to the millions of people around the world that a cure could potentially help, it really was an easy decision for me to try and get involved with some of this work and try and, like people have been saying, not only raise money but raise awareness.
Absolutely,
really close.
And so on that note, as a board chair of DRIFCan, how can people donate tonight? And oftentimes the biggest question when people give their precious money is, where's it going? Is it going to go to overhead? What are you going to do with my money tonight? Give us perspective, Matt.
So from that standpoint, there's a multitude of ways you can donate, and we'll give you a couple links here in a second. But I'll touch on where the dollars are going first. What you heard from the first 45 minutes of this stream, that's where the dollars are going. It's going directly to James and his team. It's going directly to the research. Our overhead, our costs, all that stuff are minimal. We have one paid staff that does the job of 10 paid staff, but we keep costs very, very low, so that we can maximize the dollars that are going to the research. We're committed to that as an organization. Of course, there's always things that we can do to continue to bridge that gap, to make sure that we're putting out as much of your donation dollars to the research as possible. But anything that we do, we try and keep our costs as minimal as possible, so that all of the money that's raised goes directly to supporting the search for the cure. And so the way that we do that, or the way that you viewers can do that, is to contribute through a couple of different avenues if you're so inclined to do so today. I know we've got people who are watching from around the world, so I'll give a couple of different options. First of all, if you're here in Canada, we have a direct link that I think will be going up on the chat right away to our Canada Helps page. And from what I understand, some donations are already coming through to that. Any donation over $3 will earn you a tax receipt. Again, those dollars will come directly to DRIFCan, so that the research, it will further fund the research that's going on. If you are a donor or a potential donor from the United States or internationally, we have a link that will take you to a CAF online donation page. If you're in America, that donation made there will also result in a tax receipt. And again, those dollars will end up going directly to the research that James and his team are doing in the lab right now here in Edmonton.
Multiple different ways. Bottom line, if they have questions, to go to DRIFCan.com. Is that the easiest way, Matt?
I think so, yeah. There's even beyond the links that will be sent around and all of that sort of stuff, great opportunity for you to learn more about the organization, the work that James and his team are doing, the options for you to donate, and not just saying that online needs to be the way to go. If you have some thoughts or questions or anything about how you can contribute to the work that's going on and how you can further this, our ED Melanie is always accessible, it seems. So that would be a great place for you to go and visit and learn more about this.
And I think Kathleen sums it up well with a comment. She says, it's impressive that so much money goes to the research. Happy to volunteer with DRIFCan to keep that happening. Matt, thank you so much for outlining everything tonight, a variety of different ways and options. And it really is heartwarming to hear all of that money raised goes to support Dr. Shapiro's research and his team. And I know for you, it's easy to speak from the heart when you look at your daughter's beautiful face and you realize that the work of Dr. James Shapiro and his team can change her life one day. So Matt, to all of you at DRIFCan, all the great work that you're doing and for this fundraiser tonight, thank you so much. And thank you very much for joining us. I really appreciate it.
It's my pleasure. And I thank you for all that you've done to help us get this off the ground. Thanks a lot, Carrie. I really appreciate it.
It's an honor to be involved. Thank you so much, Matt. Well, friends, that was quite an informative evening and wonderful conversation from all of you. I do hope that you enjoyed the conversation. Thank you for your time, for the early donations that are already coming in, and of course, for your participation. It means a great deal to all of us involved. And once again, if I can just recap, if you are interested in making a donation and all you have to do is go to DRIFCan, that is spelled DRIFCAN.com. It's on your screen. And I also mentioned earlier, you can do it in American dollars or in Canadian dollars. And as Matt just mentioned, all of the money goes to support Dr. James Shapiro and his team. Also, as I mentioned, this broadcast is recorded. So if you want to watch it again, you can do so. Or if you want to share it with others, please do. Let's create as much awareness as possible. On behalf of DRIFCan friends, allow me to express my gratitude to all of you for sharing your time with us, for joining us, and for supporting us tonight. We appreciate you. We appreciate Dr. James Shapiro and his team, because with your support, you enable us to change lives. To all of you who joined us from around the globe, thank you so very much, and have a great evening, everybody. Bye-bye.